So today we have a great little panel with some very distinguished speakers. We're going to talk about big data and data science, and there's really no format. We have some topics to cover, but the goal would be to have you in the audience ask your questions and hear what our panelists have to say about it. That way you can hear the experts give their opinions. Before we get started, though, I'd like to go down the panel and have each panelist introduce themselves and just let you know who they are, what company they're with, and what they do in the big data science world. And we'll start over here on the left with Michael Schmidt from Newtonian.
Hi, thank you very much. So my name is Michael Schmidt. I'm the founder and CEO of Newtonian. So we are pioneering a new technology that I like to call machine science, right? So we don't want to do machine learning anymore. We don't want to do data analytics. We want to do what a scientist would do. So we could automate a lot of these processes to figure out how things work, right? Could we take data and deduce what is a physical relationship between variables, what are they dependent on, and describe that in the same way that scientists do so we can use it for optimization, prediction, and leverage all the things you can do when you have a succinct analytical model or representation of what's going on in the data you have. It might be your dynamics of your business or anything like that. So we've built one of the most powerful engines to do this and some of the software visualization that can leverage this type of technology. So we have a product now called Eureka. Has anyone heard of Eureka before? So if you haven't, you should go try it out. It's free to test out. So we have over 50,000 users of the software now who use it for everything from academic research to try to figure out. We have used it to characterize how galaxies form in the universe, to how to detect early signs of cancer, disease, all kinds of cool stuff like that. Even in areas like retail, like modeling, what are the drivers and influencers of sales, marketing? How do I take a product that I'm curating and maximize its quality and yield and all these sorts of things? So we're basically approaching companies and helping them to plug into the data they have and be able to answer all these why questions. So over the past 20 years, there's been a lot of focus on what or search and lookup and things like that. We want to be able to very rapidly help people answer why does this happen, what's influencing it, how, and what do I do about it?
Okay, thank you. Next, we want to hear from Don Brown, who's the co-founder of Scaling Data.
Hi, my name's Don Brown. I'm one of the co-founders of Scaling Data, but more recently, or as of recently, was one of the early employees at Cloudera. I spent about 3 to 4 years there in the field and then running their global services team, and was the guy that put the first few clusters into both JPMC, Bank of America, pretty much all the big financial institutions. From there, I actually moved to a company called Weeby Data, which is more in the data science realm. You can think of them, the easiest way to think of them is kind of real-time recommendations, so Amazon in a box effectively, and their primary targets were retail institutions. I since left Weeby Data back in December. Over the last 4 or 5 months, a couple of other ex-Clouderans and I were able to raise money from Google as well as a few other VC. And basically what we're taking on is effectively a Hadoop application that basically replaces Splunk natively on top of Hadoop with a superset of the features. One of my co-founders is a guy named Eric Sammer, who a lot of you probably know of if you've been in the Hadoop space. He's the author of the O'Reilly book. I am nominally the COO, he's the CTO, and our CEO is a guy named Omer Tryman, who also is from Cloudera, and prior to that came from Vertica. So we're pretty heavily engineered backgrounds. All of us are engineers in our at least relatively recent past, and are directly going after Splunk on top of Hadoop.
Thank you. And now Jonathan Lacefield, who's a technical architect for DataStax.
Hi, thanks. So my name is Jonathan Lacefield. I'm a native Atlantan. I work for DataStax, which is the commercial provider of open source NoSQL distributed database named Apache Cassandra. And on top of Cassandra, we offer a couple other components. So we layer in analytical capabilities through Hadoop, and there's some also new stuff coming out I can't explicitly talk about, but it's going to be really neat. As well as search capabilities via Solr. So we have a distributed Solr component to our product as well. So I am not a mathematical background guy. I'm more of an engineer, developer, technical architect, right? So this is going to be fun for me, right? Because it's kind of an edge case, data science piece. When we go into clients, I typically work with two types of folks, though. Folks like myself, engineers, architects, right? Working on the collecting, the acting systems of your data. And then helping the folks who, like you all in the audience, how am I going to get to this data to analyze? So, yeah, anyways, very excited to be here.
Thank you. And then our panelist, Paco was it? No, I'm just kidding. Soon to be a science fiction writer when he wins the lottery. Since we've already met Paco, let me start with a question. One of the things that I heard in the audience during the break was, this stuff is really exciting, this workflow, all the technology, acronyms, and the ways that we can tackle these problems. But maybe it's still a little confusing, where to get started, what it all means. So I want to ask the panelists, if I was an organization, if I'm in an enterprise here in Atlanta and I want to kick off some big data, data science, analytics projects, what are some tips they would have for me, and how that would impact my selection of team or technology, or the way I view things, for instance, as a workflow. So any takers to start that? Why don't I go ahead, Jonathan.
My job is I go out and work with the user community base as well as our customer base to help them do this. And so I've seen that very small companies and then very large enterprises as well, and across many different maturity levels. There's a couple things I've seen that always work well. For companies that have an established process, right? Like the gentleman at the Big Data Week, the architect, he's worked with Teradata and SAS for a while, right? So for those types of companies, spinning off a little group that's allowed to learn, that can take a heuristic approach. By the way, heuristic approach for all this stuff is the way to go, right? You got to try stuff and it's got to work or not. Don't give those people deadlines, date-driven deadlines to deliver something, and let them learn. And then, once they have figured some stuff out, then you start what I would call productionalizing it, or turning it into kind of real deliverables-based organizations. The other key thing is to figure out how you're going to structure your people. So are you going to, Netflix, you probably know this as well, they do a really good job. They actually have an engineering arm, is my understanding, as well as kind of the computational math side, right? As opposed to looking for the people with both of those sides, and that gives them a lot of flexibility, So finding what type of people are going to make up this organization, and how you're going to approach the use cases. And then from there, it's finding the right fit, once you have some understanding of how this works and who's going to do it.
Any other comments on that? Maybe go down and come back around, Paco.
Yeah, well, definitely I'll second about that. One of the things that we've done with our teams, and I use this model in consulting, and my friends who are at some of the large consulting shops like Accenture and TCS and whatnot have a very similar view that you don't want to find one person who does everything. That's impossible. That's a unicorn. And what we do is, you might think of kind of tiger teams. I think that a heuristic approach is a really good way to say it. But rather than having like your time boxing and your hard date deadlines and all that, try to bring people together. Maybe you've got an ops person or DevOps person, and you've got somebody who understands app development within that company context, and you've got somebody else who's really more of the science role, and somebody else who understands the business issues, the stakeholder representation. And so kind of like we were saying about Netflix, where it's not just one person, but it's actually a few different teams coming together. I think there's a lot of room for having kind of these tiger teams that blend together a few people from a few different roles. And that's usually how we knock down the silos. That's how we kind of get things to change in the organization.
Let's just come back around and do the monster. Can you go ahead, Michael?
Yeah, sure. So from my perspective, it shouldn't really matter where your data is stored or things like that. There's a lot of things you can do with limited data that you have now to show that there's major value and things like that. So a lot of our customers they come to us and say, we've got huge data, and we say, all right, let's look at it, and they load it up in an Excel file, and it's very small. So some of these it's sort of meaningless, but you get the idea of, there are lower barriers, I think, than we think to establish these sort of use cases, test out what approaches will work, and actually measure what the value can and will be with very limited sets of data. And I think that it can be used for leverage to do more dedicated deployments and things like that, if the right technology is in place where you're empowered enough to do it easily and quickly for very low cost.
So I actually think there's kind of two meta problems being talked about here. So the first is how do you bring big data into an organization? And then the second is how do you actually apply a data science or an analyst team to that big data framework? And so the first one, there's really three different ways that companies adopt big data. So it's top-down driven, which is a CIO hears that big data is the next thing since sliced bread, and they want to bring it in and they just buy it without any actual plan to do things. That almost always fails. Almost universally that fails pretty badly. The second is you'll have a cost initiative that's usually driven by IT, and they'll do some sort of database offload or from Teradata or Netezza, and that is almost universally successful because they have a point problem. It's easy to prove value almost day one because of the price points that each technology operates at. And then the final one in terms of adopting a big data technology is you actually have a predictive analytics problem, typically not descriptive, typically predictive, that people want to go after almost always in the fraud or fraud security space. And they'll go after that point problem. And those I consider a mixed bag. It really depends on the sophistication of the team, how hard the problem is they're trying to solve. I find those actually be the most interesting problems to work with, but they do entail a lot of risk. The kind of other meta problem that we're talking about is actually bringing in an analytics team once you have something in place. And that's actually a relatively solved problem if you're willing to be process driven. There's a guy named Ken Rudin who runs analytics at Facebook. And what we did while I was at Cloudera was actually through a lot of conversations with him as well as the Facebook analytics team, kind of formalize and push out the process that they created there, which is basically you establish a team of data scientists that's centralized from the separate lines of business. And this is obviously an enterprise approach, not a startup approach. And as problems arise or as needs arise, you assign one or two of those data science to go embed themselves with a particular line of business for 1, 2, 3, 4, 5, sometimes even 6 months. And they work with the individual teams that are kind of embedded in those problems every day to give them a fresh perspective and to really help them understand this is the approach that people use in the market. You guys have a much deeper understanding of this specific problem and actually understand how your data looks and how it's used, and kind of melding those two. And at one point, that's some point in the future, that the responsibility for creating that solution actually falls back to the analyst and the data scientist, gets sent back into the organization to be then lent out over and over again. That is truly the Facebook model. We pretty blatantly ripped it off from them with Ken's permission. But it's what we've also found to work. I've done several dozen engagements, and this is by far the most successful model that we've seen in terms of adopting data science within an enterprise.
Okay, real quick, did anybody have any questions, follow up on this in the audience? If you do, we have a microphone up front. Feel free to come down and ask any follow-up or any other question that you want. Okay, so we're talking about big data and organization, and something that occurs to me is there's another kind of a problem, which is how do you go from the exploratory data science, purely research almost, you're generating your use case, you're hypothesizing, what your models could be, you don't know what the ROI is yet, to a big data implementation. Does that change any of the answers you guys have talked about? I mean, like for me, in my day job, I don't sit on top of a Hadoop cluster, right, and run MapReduce jobs. A lot of what I do are take samples and explore models that would be valuable, which later be translated into production system. So why don't we start with Paco and then wrap around.
Well, some kinds of problems you really have to be working at scale to get the insights, but others you can work more with samples. So I actually have this matrix that I use for management where it's got like 4 roles, but then 5 steps in the process. And I do a gap analysis on a team and a project. And so we usually try to think of like, you start out with discovery, where you don't really know much about the data. You're certainly not going to build a model. You just got to get in and do some discovery, maybe some visualization, some queries, something to kind of prove it out. I'm finding that I get a lot of traction on graph query engines for this kind of thing. It's really useful. So if you've got your data in Cassandra and then you can use some kind of a graph engine over the top of it, that makes all kinds of sense. Now, another thing would be that from there, once you start to get some insights, you want to build out your modeling. And that's where you can start to do a sample, like you're saying, build a model, and then push it in production. So I think you have to take it in stages.
Michael?
So I think one of the things that we're very focused on is empowering more people, a broader audience of people to be able to do some of these things. So you don't need to bring in consultants or a team in order to show the test out some of the approaches and some of the algorithms. So I think that's one of the areas that's been very kind of neglected recently. It's complicated to do a lot of these new things and a lot of that exploratory process because you need to be an expert in R or Python, or if you're the decision maker, maybe you don't even want to look at statistics or bar charts or things like that. But there are ways to allow people to touch the waters if you do it at the high enough level, and you can automate some of the nitty-gritty stuff for them. So I think that would help a lot with sort of the adoption process from measuring impact to adoption.
So in terms of R&D versus traditional analyst teams, I find that R&D for the exploratory research is great. They tend to do very poorly when presented with a problem that another team has been working on for years. Whether their tooling is the same is kind of irrelevant. If you've thought about a problem very deeply for years, it doesn't matter how good your big data technology is, it's unlikely that you're going to be able to catch up with people that have been working on the same problem with SAS and have hundreds of models and years of experience. And this is borne out to be true in a number of places that I've worked, particularly at the quant levels. When you go in and talk to those guys about building a new risk model for their credit, whatever credit model they're trying to build, almost universally, they can take the models that they've built, extend them, and remove a lot of the flux you get by getting rid of sampling, right? So that you no longer need to sample. And training them on big data technology tends to work much better than trying to pit them against each other, which I don't think works very well at all.
I just want to point out the very first answer we all provided. There was nothing. It was cool for me to hear. I'm newer to the big data space. The point is, it was kind of demystifying this process. There was nothing new in any of our answers from any other technology adoption piece, and I hope you all took that. This is a pretty savvy group, but if anybody's new, just take, it's the same common sense stuff. But the second piece. So your question was around discovery versus actual kind of production level modeling, right?
Yeah, I think that's a good way to describe it. It's, how do you, in organizations, how do you see that bridging occurring? When sometimes you have discovery use cases, it's hard to bootstrap off of potentially if your organization not set for that versus production use cases.
Yeah, so I probably have a little bit of a awkward skewed view from the rest of the folks here because I do mostly the production level stuff, right? So people will pull, so CERN used Cassandra to find Higgs boson. I think that's cool. So they'll pull our stuff out and do whatever they do in the discovery world. I don't see that, right? So I don't really have a good answer for this one.
Okay, so then any questions on this round? No? So what about, we talked about use cases, and some use cases are going to be better for different applications. I was talking to the panel before the break. Are there patterns of use cases or familiar use cases or common or 101 use cases that you see or would recommend to organizations, either enterprise organizations that are getting started or startup companies in this space? Well, let's start with you, Michael.
Yeah, so most of our customers have come to us and they'll say, here, I care about 10 things, right? But I've got 10,000 variables. Tell me how those 10,000 variables are impacting these 10 things that I care about. So usually, most companies have a ton of information, or they're building infrastructure to collect a lot of this information. And for them, they want to be able to know what's important and what's not important. And that's sort of the universal use case that we've seen. Things that they can do to demystify that, if they can match the assumptions that they had, they might have an idea of what's impacting that, but being able to demystify that is probably the strongest use case that we've had.
I actually had the luxury of working at Cloudera while all of these kind of use cases were being worked out, and it was emerging as to what was going to be kind of the adoption path. And it's pretty clear kind of how people go about, or how most enterprises adopt these use cases in very sequential order. And so the first use case that most people go after, like I mentioned before, is some sort of data warehouse offload, which is just SQL based. Every organization can write SQL, so if you can go after find your most painful ETL job, move that off, you have an instant win. The reason that actually my new company is going after Splunk is because that was the second most requested use case in terms of people wanting to basically replace or create some sort of distributed search across and log processing across their web logs and application logs. The next one is typically more marketing related, so you can think of it as in terms of Omniture, tea leaf type customer experience. That's obviously a really big space, not just a use case specifically, but you can kind of imagine next best action, what should I add the next item to the bag for recommendation, primarily focused around recommendation there, taking existing data and being able to predict the customer's next best action. And the one after that is almost always security and fraud analytics across a broad variety of verticals. That bears out to be true in about 60 to 70% of the cases.
Yeah, so it's neat. You have the Hadoop person and the NoSQL person sitting next to each other. So there are some common use cases there that we're seeing a lot of, specifically fraud detection security. We're doing a lot of work in that realm. So what Cassandra's really good at is like temporal time series event-driven data sets. So we do a lot of Internet of Things type applications, and there's across multitude of size of companies. So anybody startups, right, to large enterprises trying to get in that space. And it's really neat to see it actually happening now and not just being spoken about. And then of course the tried and true, recommendation, personalization pieces, just getting better and smarter at that is what we're seeing as well. There's one other piece that's starting to emerge that we're seeing, which is healthcare. There's a lot of stuff going on in healthcare, I guess, making better decisions, understanding clinical information, patient information, right? So taking the approaches that have been taken in marketing and understanding, those in the healthcare space. Probably marketing is the wrong word, but it's another area that we're doing a lot of work right now in the big data space.
So I'll put in a plug for Strata. I definitely do a lot of work with O'Reilly Media, and we have a conference 3 times a year, different parts of the world. Next one's October in New York City. But I've just read a quarter of the proposals. We had over 1,000 proposals, and I've reviewed a quarter of those so far. I don't know if I'll get the full way through this year. But it's interesting because we really try to focus on use cases, and that's kind of the benefit of going to one of these big conferences is you can, sort of like a smorgasbord, just like pick and choose. We're really trying to show not just e-commerce, but also what we're seeing out of, I mentioned agriculture, mentioned about manufacturing. They're wildly different kinds of use cases and problems, supply chain problems usually, Internet of Things, and a lot of weird areas there that are popping up. And so I would recommend that when you're evaluating what to do with big data and move in data science practices, look at what you can find out of conferences and meetups and blog posts and whatnot, and try to find other people who are in a similar area and build from what they've learned.
And one of the questions that I found, did you have a question?
If you don't mind, for Michael.
Yes.
In professional services, then when you're approached with by a company with these 10 things and 10,000 variables, can you afford to use a data scientist to help explore how you work with that customer, or do you use some of your expertise from prior history of, we got to look at your data MDM perspective, or we got to look at your quality of your data? Again, do you think a data scientist needs to be thrown in that problem immediately up front?
So I would say no. Ideally, no, never. You don't necessarily need the data scientists immediately or things like that. But we've seen pretty diverse set of customers where they want to be able to match the business context to the data they have. They want to kind of bootstrap with you as they start to explore some of these patterns in their data for the first time. So there's a lot of things you can do to make it easier, and I can't claim that we can solve that entirely where you don't need the right level of expertise for a lot of this stuff, but we're progressively getting better and better and better at making it easier and easier to test things out without a data scientist.
Any other panelists have thoughts on that? No? Yeah.
There's a value there to get another set of eyeballs. And I like to do this with my teams, is not just have one analyst on a problem, but have multiple. And a lot of that's organizational. And I find that as I've gone in and built out analytics in more traditional businesses that didn't have it, the big thing we run into is there's usually some leader who has an idea and a vision, and the data better damn well fit that vision. And usually they try to craft whatever message is coming out of analytics to fit their vision. And until you can get enough of the data put together to get the COO or the CEO to just say stop, usually whoever argues the loudest, the longest wins. So I think there's a lot of value that if you are in that situation, get somebody who's agnostic, whether it's a data scientist or what. I mean, get some multiple eyes on target.
So just to follow up, so we've had a couple of customers come to us where they'll have, it'll be one of the decision maker, and what the data they can get access to would be something like their dashboard per business unit and things like that. So it's hard to get a lot of value out of the sort of high level data, but you can play around with even just that simple example of a data set where they can get access to it, if they get it mailed to them probably every week or every day. And usually in a format that's pretty simple. It's small and boring, but you can show and prove that you can find some patterns in the maybe stuff you already know about, but that's one avenue we've seen where a high-level decision maker can test things out without having to dive into all the big data sources out there.
To Paco's point a second ago, I actually think that, and we push this really, really strongly as a vision generally in services around data science, which is keeping your data scientists, whether a business, regardless of the title, keeping them independent of the lines of businesses that they're actually analyzing is critical. Because if you're an analyst that works in a concrete example of this that I actually went through was a very large retailer. They have various groups doing modeling, and they're all fighting over their piece of the attribution model. And so some of them are bulk mail, some of them are email, some of them are the ads you click on the site, and everyone wants to fight over their little piece of the pie that they're going to get credit for. And if you don't have someone that can kind of sit astride that entire organization, that more typically is going to report not to a technology person, but even a CFO or CIO outside of the IT org, and kind of can call BS on whatever numbers they're throwing out there, that's truly critical. Because otherwise, it's very easy for most data scientists and even most engineers to snow people over with numbers. And you want to be able to actually have a real mathematically rigorous capability to counter all of that.
Like 5 product managers all claiming 10% lift?
Exactly.
That's 100% lift now.
You have another question?
Yes.
So continue that. So in organizations that are, can you hear me? You can use it. So in organizations that are obsessed with quality, how do you come up with test scenarios or test data when you're doing discovery analytics? And how do you convince the people who are obsessed with quality that you're doing the right thing?
I mean, it's really important to use confidence intervals and predictive bounds and these kinds of statistical techniques. I mean, one of the conceits I find about it, I'm a big fan of machine learning for many years, but you can kind of think of like machine learning in industry does a lot of heavy lifting, but it'll allow you to make billion-dollar mistakes, whereas the more rigorous statistics, where you come in and quantify error and risk and assess the quality issues in a very rigorous way, the stats can hopefully prevent you from making the billion-dollar mistakes. So the two have to be taken together. If you look at the large search engines, they'll do their heavy lifting with machine learning, but they'll have a small army of statisticians handling the edge cases just to get that quality.
There are actually a number of startups kind of in the space solving that particular problem, Trifacta, Data Tamer, basically data hygiene, data cleansing. And you'll hear all the data scientists I know say they spend, Josh Wills at Cloudera calls himself a data janitor. He spends 90% of his time cleaning up the data, ensuring data quality, and 10% of his time actually doing data science. Scenario for most enterprises and even most startups. And I honestly don't, the tooling can get improved. I don't think there's ever going to be a world, at least in the recent future, where all of that cleansing, because you simply don't know what to throw away until you get in and start getting your hands dirty.
Okay, so one of the things that we talked about were these use cases, and I'm curious now. Oh, yes, question? Yes.
So a question related to what was previously said about the data scientist, not related to the actual department.
Centralizing data scientists.
Well, it's not connected to their boss is not.
Yeah, it's conflict of interest.
Yeah.
A lot of business.
Contradict what maybe the line of thought of the CEO. So is there a merit to bringing somebody from an outside, like a data scientist from the outside? Is that commonly done?
I typically see it in the form of auditors. I mean, so eventually these companies, the large ones anyway, are going to be audited by some sort of KPMG or Deloitte type world. And it just depends on the problem that they're solving as to whether those auditors are actually going to look at models or not. If they're solving something that's very public facing, they probably are. If they're solving an attribution modeling problem, they're probably not, because all the kind of public-facing world cares about there is the final number. They don't care about anything underneath that or the subcomponents of it. So it really just depends on the problem that's being approached.
I think also to your other point about CFO, I really like that hub and spoke model of having like a center of excellence that gets farmed out. We've used that a lot. We were actually talking, when I was at InView, I was talking with Jay Parikh, who ran infrastructure at Facebook about that. One of the things that's really important is corporate sponsorship. And so it does get back to your line of reporting. I've found that running a large data, or running a data science team with a fairly large mission within a company, if I was reporting up to the CFO, it worked well, worked wonderfully. If I was reporting marketing, I was in trouble. And reporting engineering was kind of hit and miss. So I think that finding the right corporate sponsor is hugely crucial. I mean, aside from auditing is also a really good point too, having the independent side.
And one thing that we also found as part of the model, again, the Facebook analytics model, is at the end of any major push or effort, it should be, I mean, this should be part of the policy as you're creating programs. You have to publish the result of that company-wide. And anybody that wants, you can go look at the methodology. They can look and see how that was created. That ends a lot of shenanigans on who gets credit for what, because no one wants to be called out publicly within their company for doctoring numbers effectively, or at least exaggerating numbers.
Okay, what about, we talked about, well, one of the things Paco introduced us to is this workflow idea. What kinds of, well, at the end of your slide, Paco, you were blitzing through a lot of different technologies. And some of the commentary that I heard was, this is all really exciting. How do we know where to spend our time investing in those technologies or in the organization or in other skills? So yeah, some tips for this.
Yeah, there's a really great article. I actually took it out because too damn many slides, but there's a really good article by Steve Yegi. It's called Notes from the Magical Mystery Bus. And the point that he's making, I mean, it's a long article, but the point he's making is, I mean, there's a different characteristic, different organizations. And so something like KNIME is great for, you know, biotech firms where you've got all these chemists doing things, and they're not going to worry about where the log files are coming from or the data engineering. Somebody else can probably take care of putting together modules for them for system integration, and they can focus on the chemistry. But you know, if you're in more of an anti-fraud situation where you really have to get the real-time signal off of a lot of complex different logs, you've got to do the engineering right, it's going to be audited, you probably don't want that kind of tool. You want something that's much more operational, and so that's where, you know, like a cascading or something comes in. So I think it shifts on the, based on the organization, what kind of tools you want to use. It's largely about the risk in the organization. So I mean, the point that I make is if you're Pinterest, you can roll out a new feature, and if there's a bug, you can push out, you know, an update 15 minutes later, no harm done, all in the name of innovation. But you don't want your airline doing that, and you don't want your bank doing that.
Listen to my favor.
It's to that point. I forgot the gentleman's name, but at a conference last year, Spotify was speaking, and they were like, you know, our playlist counts are completely false, but it doesn't matter, right? People just want to see stuff's going up. You know, I think that's cool for Spotify. You know, for banking company, probably not so much. But yeah, from data engineering, that's my little world. Speak. So Paco mentioned functional programming. That is very important in the at-scale world. And also, so the kind of the hot darling right now in the data world that we're seeing is Spark, and on top of that, Shark. So that's definitely worth your while if you're trying to get in some cutting-edge stuff. That's coming about in all the Hadoop distributions. DataStax, Databricks is partnered there too. But those are probably two good places. And of course, good old-fashioned Linux, Python skill sets are always going to be needed.
So I think that you have to unless you're starting from a greenfield, which most places are not that I work with anyway, you have to let the team dictate the tool chain, and that dictates obviously the workflow. And so if you have primarily traditional business analysts, they all know SQL, you're probably going to live in a Hive, Impala, Drill type world to do at least the pre-processing, and then you may eventually convince them to write some code, but even then it's likely that you're going to be doing a lot of the actual analytics in a SQL abstraction on top of whatever your framework is. If you have more of a kind of math PhD group that's been doing quant type stuff for years, they're going to want to use SAS or whatever they're comfortable with. And so we've come a long way from when I started using Hadoop back in 2007-8, where you wrote MapReduce, and that's what you did, and you did it in Java, and you liked it, whether you liked it or not. And so now Spark is coming along. Scalding is particularly interesting on top of Spark, and really on top of anything at this point. And so I think the important message to take away is, whatever your skill set, there is an emerging tool chain and workflow that will probably support it, and go that way rather than trying to optimize for picking for the latest and greatest and the shiniest object out there.
Don't learn MapReduce unless you have to.
Yeah. Well, yeah, MapReduce is a decade old.
It is.
It's
like more than a decade.
Well, it's 50 years old.
Well,
it came out of Lisp in the 1950s.
If we want to go back to Curry and all that, yeah, we can go back to the 30s. But I mean, the Google representation of MapReduce and what Hadoop picked up, it's based off of data center economics from over a decade ago.
And it's still good for big, multi-billion row joins, but it's not necessarily good for the type of analysis that data scientists are generally going to be doing.
Or for a small company. I've seen companies back off and say they need it.
So what about any top tips for big data disaster? If I wanted to sync my big data effort for some reason. Have you guys seen these? I don't actually want to do it, but you must have seen some mistakes and some misconceptions, maybe even some patterns in these. So what are some of these that you can share?
Legal. The biggest big data disaster I ever saw was legal. I was at a company that got a DCM, is it DMCA, DCMA? I can't remember.
DMCA.
They got this lawsuit. And they knew that they could dismiss the lawsuit because it was actually Mogul files. But they had some user-generated content. They had a lot of log files that would demonstrate that they'd been agnostic and they weren't at fault. And nobody had ever looked. There was like 8 terabytes of log files, and we had a few days to answer. And so we went in and set up Hive clusters and went in and got the answer. And as soon as we had that capability, the product managers came in and was like, aha, we're going to use this. And CFO said, no way, absolutely no way. Take that down, get rid of that data now. Because if we had introduced that capability, we'd lose the sort of common carrier status, and we'd be open to more lawsuits. So legal is the biggest big data meltdown that I've seen.
One of the ones I've seen is automated joins. So we mentioned a few of there's companies around ETL and getting data and connecting it together and joining and things like this. So there's a lot of tools out there that will do automated joins. So we've talked to a couple of customers where they'll use these tools to get their data into our system so we can start analyzing it and crunching numbers on it. And they've told us a lot in the past that they'll never use automated joins again because they've had experiences where the join was not quite right. It was throwing away fields it was doing an inner join or it should be doing a left join, things like this. They're fundamentally measuring the wrong thing, and it took them a while to actually figure this out. Another one. This is actually my first job was at GE. So this is way back in 2000, early 2000s, and they stored all these CT scan images on DVDs, and they had a big stack of DVDs and a robotic arm that would go and pick out a DVD and put it in the drive right before we had all this distributed storage. So they had a big disaster, and this just came to my mind, is the robotic arm was malfunctioning. It would pull out the DVD halfway, then move the CD, and then snap it in half. Right? So this is a huge lawsuit for them. It's sort of a disaster that I think we don't have to worry about anymore.
Magnetic tape, man.
So I think understanding, quite frankly, there are trade-offs with moving to these technologies. So the most forceful example I can give, I can't out the company, or you would all probably be up in revolt, honestly, after you hear this, is they were moving to, they had a very enterprisey messaging bus system that they had been using to basically transfer events from their fraud and security system, which included log events as well as transactional details, into an analysis platform they built over the preceding 15, 20 years. And they wanted to move that messaging system over to a more modern system for capturing data. And again, I won't actually out the tool even. But what they didn't realize was all of the kind of legacy messaging queues, or almost all of them, at least the ones that they had explored, had always had guaranteed delivery. And what they didn't realize when you go into a horizontal scaling mode is a lot of those tools don't have guaranteed delivery. And so they were dropping events. And they weren't dropping a few events. They were dropping thousands to hundreds of thousands of events a day and didn't even know it was happening. And so I got I won't call it angry, but a terrified call from their chief architect in the middle of the night one night saying, we just realized we've been dropping thousands of events for months, and this is a card processing company. So these are really important events that they're dropping. I need you to get here tomorrow morning as fast as you possibly can and fix this. And so just understanding what the trade-offs are as you're going into it, and not just think that like this queuing mechanism is a drop-in replacement for MQ or whatever we've been using for years, and it should work the same. And I've seen, that's the most drastic example, but I've seen that example play out in several different ways.
Question in back.
How did we fix it? We turned on the guaranteed delivery feature of the tool that they were using. It was really a simple config problem. They just didn't quite know what they were doing.
There's no coincidence that his company has been funded, by the way, recently.
Now, there is a difference between the performance characteristics of each mode, and so it did require some re-engineering of the actual ingestion system, but that was mainly just adding a bit more hardware. It was a relatively easy fix. It's the business consequences that were relatively large.
Durable rights equals true.
Yeah, something like that.
Common sense stuff, right? Again, go back to learning and whatnot. These are new technologies and there are trade-offs. Biggest disasters. So for folks who haven't, I'm going to go NoSQL as opposed to Hadoop here, just because give a different opinion here. For folks who haven't worked in a system that's distributed where you could get different answers, consistency is what it's called. So that's eye-opening when you're working with a distributed system and you're doing things like writes, where you're not taking into account what's called quorum, and so you write something here and you read it back over here and it's a different result, right? It's easily tunable. It's something, if you haven't worked at distributed scale yet, though, that's always interesting to see for people to experience that the first time. Another one for the Hadoop space, I personally experienced this, and it kind of bit me in an application, was the speed at which MapReduce-driven applications execute at scale. So if you write something that works kind of well small, and then you go run it at scale, and you haven't run it at scale before, and that's the first time you're seeing it as in production system, that's a little scary. We used to always talk about performance testing even back in the relational days, but it's really more challenging now to do that scale, which is what's cool about Mesos, right? Because you can do that without having to build out a whole other infrastructure.
It actually brings up an interesting point around there is a lot of extra costs moving to a big data world particularly around performance testing, QA, that sort of thing, that people think that they can ignore just because it's going to be tremendously more expensive. And I'll give you a concrete example here of, and again, I can't out the company, but the largest handset maker in the world basically was developing an application directly on a developer's laptop, and it was going straight into production. That scaled for about 3 weeks, and then they had a massive outage. And they just simply did it just because they could save a few tens of thousands of dollars, but the outage cost them several $1 million. So be aware that just because you're now operating on tens, maybe a few dozen, maybe a few hundred machines, that doesn't really change the way that you should be doing testing. I mean, the patterns are still roughly the same. The size is just different.
That's actually pretty common, right?
Yeah. Any questions on that? Okay, one last question here. So there's so much going on in this space. When you have free time, Friday night at midnight before you go to sleep, what kinds of ideas or technologies or thoughts capture your fancy? Let's start with Paco. Aside from writing
this is going
science
to take a while,
fiction
I
books.
imagine, right?
No, you know the side project lately. I've been working on a little project with the CTO at O'Reilly, and their team, what we've done is we've taken the books and wrap them isn't the right way to say. We can take the books that we create and we can generate IPython notebook, and then we can run those in Docker. And there's some Vagrant in there too. But the idea is making the books executable so that like a conference here, we can just launch it out in the cloud and everybody can be running their own instance basically.
And you're releasing that soon, or?
Yeah, actually we're going to demo it in July. So.
Okay. You can follow your blog on that. What about you, Michael?
I don't know. So I'm fascinated by the potential for algorithms to make discoveries, like scientific discoveries, directly from data, especially about complex systems that a single human couldn't do alone, right? So it used to be that a lone guru could go off, disappear for a few years, and come back with some grand unified theory of how something works. But the stuff that we want to tackle today is probably, in most fields of science, sort of thwarted by that complexity, and we don't really have the tools to go about picking things out and decomposing the problem in an appropriate way. So a lot of fields of science sort of stagnated around the complexity in these frontier problems. And so that's the thing that I think about probably is how can we leverage some of this technology to have a major impact in how we scale with the complexity of things that we want to solve. So there's a famous physicist, Steve Strogatz, who recently was on NPR talking about we live in kind of a very special time in history where all of the discoveries, all the scientific discoveries, we can still do them ourselves and appreciate the answers. But his point was that time's pretty soon coming to an end, and that we need to be able to scale beyond our current limitations. And so I sort of think about how we can connect technology to be able to do that. And the cool thing today is we have so much data that maybe some of that data will point us in the right direction and help us, instead of having to try everything in science, test everything, figure out what's important first, and then narrow in faster.
So I'm a generalist in IT. I started doing encryption research at IBM when I was 16. I've done Java mobile development. I've been an infrastructure guy. I've been a security guy. I've been a data warehouse guy. Now I'm a big data guy. So I've done a bit of everything. And so throughout that, the way that I've kind of picked to learn, and I've in the last 2 months, I've had a kid and raised money, so I haven't really had too much to do this lately. But I always apply things to the same problem so that I can see kind of the evolution of how I think about that problem and how the tools affect the way that I think about it. And so my background is primarily finance. And so I in almost every case, I approach new technology from a simple arbitrage problem. I do pairs arbitrage for a couple of instruments, and I try to figure out what's interesting, whether there's anything interesting there, or in the case when I got to Hadoop, I did it at scale. And so rather than doing 2 or 3 or 4 instruments together and trying to figure out if there was nice correlations and whether you could kind of make money off of that, I then did basically a matrix of every stock price for 10 years against the New York Stock Exchange, NASDAQ, and pretty much everything I could get a hold of. And so the problem remains the same, the technology changes, and I think it's actually useful to keep it in the same domain because it really helps you understand the technology in a much cleaner way if you apply at least roughly apply the technology to the same problem.
Chris? So I've been playing a lot with Spark, Shark, Scala. So going into this whole functional programming world, I'm an object-oriented guy, so that was had several arguments with friends, and then they finally convinced me, and now I've seen the light. Yeah, so I was telling these guys, my mantra is no shared mutable state in any kind of development environment at scale. In addition to that, I like to read like weird stuff that's peripherally here. So there's a guy named Nassim Taleb, right? So I like to read a lot of his stuff, which kind of contradicts the big data, statistics, the world I live. So it's kind of fun to try to mesh those two thought processes up as well. So.
Any last questions? Any last comments from you guys? Your farewell. The plug for the book, the plug for the software product. Let's go back through this again. So Michael, you have, tell us about Newtonian and Eureka again.
Yeah, I was going to ask where the nearest Waffle House is, because I'm from Boston and I
North side. It's right
not tried it yet.
Oh, you need to go to the restaurant next door.
Oh, okay.
Which is that?
Yeah, Silver Skillet?
Skillet, yeah.
Okay, okay.
So, closing statements? Is that
Yeah.
Okay, sure. So, we're kind of a cool stage of our company where we're scaling out our technology, we're testing out on new applications and use cases for the first time. And it's a lot of fun seeing what pops out of some of these different types of data sets. So I really encourage you to go out and test out kind of this type of approach, look up Newtonian and test it out if you like. Feel free to contact me. It'd be interesting to hear about what you find in that sort of data.
So I'm hiring aggressively. So if any of you are interested, you can track me down, Don at Scaling Data or 10 Sigma on Twitter. And really, what I'd like to take away from this is I like to see people coming to data science cold from kind of a legacy. And for me, watching them learn teaches me more than reading any number of books that I try to read. And so my passion is kind of seeing this technology actually hit the enterprise as opposed to in academia where I've kind of seen it over the last 10 to 15 years. And taking that and applying it is particularly interesting. And so again, going back to the previous comment around how do you learn things, also a takeaway from here is to take papers that you see that are interesting and apply them to interesting problems that you know of that may not have anything to do with necessarily the paper itself. I find that really fascinating and you get a lot of interesting results out of it.
Just real quick show of hands, how many folks are running like what they would consider a big data application in production? Yeah. So to your point, one of the neat things, I get to travel all around the country. I'm not worldwide yet, but like Atlanta is just starting to adopt where on the West Coast there's a lot of mature stuff, and it's kind of fun to see all that stuff. But yeah, so if any of you guys, I'm local as well, so we're hiring probably not as aggressively as he is though. You want to hear more about what we do or just talk about the space, feel free to hit me up. My contact information is here. And
I'll put another plug for Strata. I really enjoy working with meetups and conferences and all, and we're trying to build out more on the East Coast. I think that probably the New York location is a little bit closer geographically, and we've definitely been building that up along with Cloudera. So I think that October Strata is going to be pretty good, and definitely hope to see some of you out there.
Plus book and workshops.
Book too.
All right, thank you, everybody. Travis, any closing administrative items?
Thanks so much to our panel. They're very busy people and are willing to spend their Saturday with us, so we're very fortunate to have them. So thank you very much. Thank you to Andy.
Thanks, guys.